To the session. Today we're going to learn a little bit about server-side WebAssembly and Spin. My name is David. I'm the founder of the Raw Code Academy. Just out of curiosity, has anyone heard of it? Awesome. It's a YouTube channel that wants to help people with cloud native and Kubernetes. So if you want to learn about the tools in this space, of which there are many, then hopefully my channel can provide some assistance. If you want to tweet or anything like that, Raw Code's pretty much everywhere. And we have an active Discord server where we just complain about Kubernetes all day, so feel free to join and vent away. Now, I'm going to start by just talking about what cloud native is, because I think we're going to be moving as a bit of a transition, and I think WebAssembly is a huge part of that transition. So I want to kind of talk about where some of the challenges are right now with cloud native development. So the cloud native definition used to be really, really simple. It was three things. One, that applications are containerized. Two, that they're dynamically orchestrated. And three, microservices. Not that microservices are simple, but you know. This is not the definition anymore. This is now changed and evolved as cloud native has evolved too. And we now have a rather, not verbose, but chunkier version of what cloud native means. And what's nice about this one is it was actually defined by the cloud native community. So people can go to the GitHub repository and change this, send an update. But this is because cloud native isn't just those three things anymore. And that's because in 2 years, the CNCF accepted 15 projects into the CNCF landscape. Obviously now, it's much larger, and the scope of what we're all doing is getting, well, more complicated. And in a weird way, cloud native actually encompasses serverless architectures as well now. So it's not the fact that we're doing microservices, it's the fact that there are different paradigms to what cloud native actually means. Now, I don't know if anyone remembers unikernels. No? There's this wonderful promise that we would have an architecture that kind of evolved containers to the point where every single request to an application would be spun up dynamically, processed, we'll get a response, and then shut back down. And this would all happen with a unikernel. This company that was leading the charge here, based in Cambridge, was actually bought by Docker. Justin Cormack is now the CTO of Docker, and he was leading this. But now we don't have unikernels, so I'm not really sure what's going on there. We've also seen serverless architectures with Lambda, OpenFast, Knative, and we now do a lot more event-driven stuff as well. So bring in asynchronous programming to cloud native through tools like Cadence and Temporal and even Prefect. And then we've got WebAssembly and the WASM specification. Now again, out of curiosity, is anybody writing any WebAssembly today? A little bit, okay. Yeah, so cloud native had to evolve because we have these new patterns, we have these new technologies, and people want to experiment with technology. I always say I'm a bit of a technology magpie. Like if I see a new technology, I have to go and start playing with it. So this brings us on to WebAssembly. And now, of course, I'm not going to get this tweet loaded, am I? I'm on Wi-Fi. Let's see if that works. No. Oh well. This tweet was from Solomon Hykes. He basically, everyone knows who Solomon is, he was the founder of Docker. Yeah, of course. He tweeted many years ago, and I'm sure he hates the fact that people bring this tweet up, but he said if WASM had existed and WebAssembly had existed in 2008, they wouldn't have had to build Docker. Now, I think that is a testament to just how ambitious the WebAssembly and WASM specification are for building applications today. We use containers because we have applications that need a kernel. WebAssembly is different in that we run all of our code in a sandbox, and we can give that sandbox capabilities. Now, if we don't need containers, we have a new paradigm for developing applications with a strong developer experience, and that's kind of what I would like to focus on as part of this talk. What's really powerful about WebAssembly is that it's language agnostic. So you can write your WebAssembly applications in Rust, and TypeScript, and JavaScript, and Python, and Go, and so forth. And I've got a massive list of languages that are supported. Some may surprise you. It's also host agnostic, and it doesn't care if you're on Linux with a Linux kernel. It doesn't care if you're on Windows, and it doesn't care if you're on Mac, and so forth. And architecture agnostic, which has never been more important as we're all rocking M1 Macs these days, right? Anyone tried to pull a container image that doesn't support ARM architecture, right? You're kind of left just screaming, going, I hate this, I'm going to go be a farmer, or whatever your dream job is. I'm sure it's not this. So WebAssembly does tackle all of these problems that we have with cloud native development. Now here's a list of languages. Hopefully your favorite one is up there. And I just love, people always ask me if WebAssembly is, is it ready yet? Can I start doing this? Like, if you can write a program in brainfuck, I'm going to say WebAssembly is ready. Even Fortran.
You're missing COBOL. Is that supported?
Oh, I was about to say even Fortran is now supported, and now we've got COBOL, right?
Where's assembler?
Come on. That's not the point. The point is, pick a language. The chances are you can compile that to WebAssembly, which is really sweet. Even Go, with the recent release of 121, you don't really need to rely on tiny Go anymore, which is awesome. We're now even seeing new languages born that are WebAssembly native, right? Now, you can't really build anything useful in Grain yet, but it's a language that only compiles to WebAssembly. And again, I think these are exciting developments because, again, it shows that the maturity of the project is there. The adoption is getting there, and we just, we need to invest more time, and we have to learn it and do cool things with it. So Grain is awesome. As far as host agnostic, doesn't matter what operating system. And there's even a WebAssembly native operating system now called KWAST. Now, it hasn't been updated in a couple of years. It was more of a proof of concept, but the fact that we can do these things is really exciting. So we need change. And it's because developing today has many, many challenges. So there is the Mac problem, of course, right? We're all on M1 Macs. If your container image isn't supported, you're in a bit of a pickle. You have to build multi-manifest container images, which has got its own problems. I'm not sure anyone actually enjoys that. Then there's the macOS file sharing thing. And I'm going to just keep hammering on about macOS because it's what I run, right? But if you work with a dynamic language, then when you develop against a container on your Mac, you have to sync all of those code into it so it can be executed. Now, they've been trying to solve this problem for years, but the problem is it's just not performant enough still. So I don't know if anyone's a PHP or Ruby developer, right? But all the examples show how to do hello world, which works great because it's like a handful of files with no dependencies. Once you've got a node modules folder, or you've got a vendor folder with PHP, etc., and you're syncing tens of thousands of files into a virtual machine running on your machine, then a container, you're waiting 5 seconds for the reload. And as you make a change, that's just really not good enough. We also have cold start times. This is more important for like serverless architectures. So if you want to spin up a container for every single request that comes into your system, which is zero trust and isolated is kind of a cool idea, but the startup time for a container is measured in hundreds of milliseconds. So if you get, again, it works well if you've got a dozen customers who make a request every few seconds or whatever, but when you've got tens of thousands to millions of customers, that's just not going to scale at all. Then we've got container image sizes. I'm sure we've all done this, where we've done a Docker build and we've spat out a multi-gigabyte container image. It's just not good enough either. We want to be shipping container images, ideally, that are megabytes, but with WebAssembly, these challenges also disappear because WebAssembly binaries are quite small, as we'll see. We then have the fact that containers in Kubernetes require a networking sandbox, a POS container. They have infrastructure concerns and costs just to get all of that running. Now, these are mostly negligible and are not a reason to switch to WebAssembly, but the fact that they disappear as you adopt WebAssembly is a very interesting concern. And containers are sandbox, of course. We've got C groups and Linux namespaces to kind of make sure that the containers don't do bad things. However, it's not really a sandbox. There is ways that you can kind of screw that up. You can run privileged containers. You can expose the process files, the process namespace from the host, and so forth. So you have to then learn this entire security ecosystem. You have to learn what seccomp filtering is, and you have to apply this to run containers safely in a production architecture. Again, with WebAssembly, we get a sandbox that really doesn't allow you to do these things. So let's talk about the developer experience, right? I'm assuming most of us run Mac or Windows, so that is a challenge. Now, every time I talk about these challenges, people just say use Linux. I have been using Linux. I was a desktop Linux user pretty much my entire developer life. I was an Arch Linux user. I have to say that 3 times during this talk. But it's just not the answer. I didn't enjoy using Linux. I'm productive in Linux, but you have to struggle with Linux, right? Whether it's moving from X11 to Wayland, whether it's trying to get your GPU to work and render applications properly, whether it's font scaling or anti-aliasing, everything is a challenge. Everything needs configured. It needs set up. And while I would love to say that desktop Linux is coming, let's just face it, right? It's never going to happen. And I know people are going to hate me for that. But Mac, things just work, which is always the answer. And it shouldn't be important, right? When you show up to work and you want to work on your application, if you want to run Windows, go for it. If you want to run BSD, fine, whatever, right? We need to remove this from the development pipeline. Another challenge with containers is that if you do adopt a microservice architecture, being one of the tenets of cloud native principles, right? You can't run that entire architecture locally. And I'm not saying that you should try either, but WebAssembly does enable some things that allow us to improve the developer experience here too. Now, what I've seen, I consult with companies and I try to help them adopt microservices, is that the first thing they do is spit out a Docker Compose file with their 20 or 30 services and try and run everything on a developer's machine, and then it falls over. It's just not going to work. You need to start using remote development environments. And Metro D is the one that I always suggest people check out these days. If you've not heard of it, go check it out. Open source, really cool. Doesn't care what operating system you're on, it just works. But we need to improve how do we build a microservice in isolation, but still confirm that it conforms and works in the broader picture, right? So WASM can help. And the reason that WASM can help is that the cold start time is measured in milliseconds, usually 1 digit, right? So you can start a WebAssembly binary in 1 microsecond, 1 millisecond, not a microsecond, that'd be impressive. It doesn't really care what your architecture is. Now again, when you adopt microservices, let's assume they're all WebAssembly. I'm not saying you should run them all on your local machine, but it does become an option. And the reason that that becomes an option is that if you process or send a request into your entry, say it's an API gateway, WebAssembly binaries will be spun up on demand. So if you do a user registration request, API gateway, the WebAssembly runtime can spin up that WASM sandbox, execute the request, and then it shuts back down. In theory, you could run an entire WebAssembly architecture on your machine and use 0 compute resources except for the requests that go in, because everything is actually dynamically orchestrated. Not dynamically orchestrated like we pretend with Kubernetes. So again, I don't encourage it, but in 10 years' time, we could be doing something like this. And this is just something that Kubernetes doesn't really do well. Again, because we have POS containers, network sandboxes, everything needs an IP address, everything needs a process ID, everything needs all of the stuff that a Linux kernel process needs. So then when we look at WebAssembly, things get nicer-ish. Now, there's a project from Google called Service Weaver. Has anyone heard of that? Okay, cool. They're trying to tackle this, but with containers, but trying to fix this local developer experience. So what they've said is, well, if you build your application with Service Weaver, everything becomes a function. Now, what happens with that function is that you get the dynamically orchestrated thing, right? The code path only runs when the request comes through. However, when you build it, each function is deployed independently as a container and deployed to a Kubernetes engine. So it gives you this really great developer experience where you can build a monolithic application in a single code base where everything is a function, every service is a function. But the deployment does it the proper way, at least the Kubernetes proper way. So, even if you walk away from this and you think, WebAssembly isn't for me, go check out Service Weaver. It does mean you have to write in Go, but I mean, we're at a Cloud Native conference, so I'm going to assume most people are writing Go anyway. Caveat, it doesn't actually deploy to Kubernetes, it only deploys to GKE. But apparently they're working on Kubernetes support, so fingers crossed. Now, this is the old saying from the Docker marketing docs, which they don't really use that much anymore, but it was build once and run anywhere. I think we can all agree that that's not true. You can't run it anywhere. But again, with WebAssembly, you can. I could compile a WebAssembly binary, stick it on S3, and anyone can download it and run it, provided they have a WebAssembly runtime. So we are close to where we need to be. Now, with regards to WebAssembly, where are we now? Can you adopt it? Should you be building things with it? If we look at the CNCF landscape, we can see that Envoy is already using WebAssembly as an extension point. Now, of course, Envoy is written in C++, but you can write WebAssembly code and ship WebAssembly extensions to modify the behaviors, which is really cool. There's then a project called Crystlet, which is now mostly deprecated in favor of other runtimes, but this was a Rust-based CRI kind of kubelet implementation that allows you to run WebAssembly workloads inside of a Kubernetes cluster. We've also got WASM Cloud and WASM Edge, which are sandbox projects in the CNCF, which are runtimes for running WebAssembly too. So the cloud native kind of adoption of WebAssembly is definitely growing. There is momentum, and people are doing really cool things with it. There's also a project called KWASM. Was that a question? Kuborden, yeah. Yeah, it does policies as WebAssembly, which is really cool too. It is a very cool project. I think it came from the team that built Harvester. What are they called? Rancher. Yeah. There's also a project called KWASM, which is a deployment vehicle for RunWASI. I'll talk about that in a minute. And then outside of the CNCF, there's loads of things happening in the WebAssembly space, right? So Cloudflare Workers supports WebAssembly, so you can just write in whatever language you want and deploy it to their edge network and do really cool things. There's a company called Cosmonic, which are doing really cool stuff. There's Spin, which I'm going to do a demo and walk you through as well. There's Suborbital and Atmo, and then there's WAP PC, which is like a gRPC replacement or remote procedure calls built on WebAssembly too. So again, now is definitely the right time to start saying and taking WebAssembly seriously. And of course, we've got Docker, right? I mentioned them at the start. They bought the unikernel company. They swallowed that up. But they're supporting WebAssembly now too. And in fact, most of Docker's major developments in the last 12 months have been to support WebAssembly workloads. So with the new versions of Docker Desktop and the new versions of Docker Compose and the Docker CLI, you can build WebAssembly container images, push them to the Docker Hub, and pull them in a Docker Compose file to run them side by side with your container-based applications. So now, when we're talking about cloud-native architectures, WebAssembly is almost a key component of that, or at least it can be if you want it to be in your architecture. Docker Desktop does support a bunch of WASM runtimes, so Spin is one of them, and I'm going to kind of play with Spin, and then there's the other ones. The registry support is just awesome, right? Being able to push these WebAssembly binaries into a container registry and pull them in your Kubernetes cluster is just wonderful. And being able to spin them up with Docker Compose is an exciting time too as well. So I think that Cloud Native 2.0 is going to be this hybrid architecture of containers and WebAssembly. Now, containers aren't going away. I'm not here to tell you that you should just start writing WebAssembly and say goodbye to your containers. There's obviously a time and a place. But if you need a database, I'm not suggesting you go and write one in WebAssembly. We have Postgres, we have MongoDB, we've got FerretDB, all these other cool technologies. So we need to build a future where containers and WebAssembly do run side by side. And this is where the RunWASI project comes in as well. So obviously, Docker Desktop is great for your local machine, but you want to run these WebAssembly workloads in a production cluster and schedule them next to your Postgres and so forth. And RunWASI is a containerd shim that allows us to schedule WebAssembly workloads inside of a Kubernetes cluster. It supports all of the major runtimes. It's got support from Docker, Firmware, Microsoft, and others. And KWASM is the project that you, yeah, it's here. Maintainer here, creator. Their mission is to deprecate themselves, right? You want to deploy this shim to the cluster, but we're hoping at a future where you don't need it. But right now, it's a fantastic approach. And I believe you're giving a talk on this later, tomorrow. So go check that out. So now I'm going to show you Spin and a real application that I built that you can all play with in your browser and just kind of show you how this developer experience is much better, hopefully, than working with containers. All right, let's see if I can do this correctly. Okay, so we have an application here, and if you want to check it out, you can actually go to quiz.rawcode.win, and it's the big fat Scottish quiz. Now, this is it's going to dynamically generate questions by speaking to OpenAI, and it's going to do it in a Scottish fashion. So if you've struggled with my accent so far, you're going to be really fucked when you try and do this. Now, you get to pick a topic. Let's just say we want to do cloud native, and you can specify your own difficult level. It defaults to moderate. You can put anything you want in there because OpenAI is going to interpret it. There's no predefined thing. You can't, you could write hard, but maybe you should have a bit more fun with it and say extreme difficult mode or whatever, and see what you spits out. But if we hit submit, and it's slow just because OpenAI is slow, not Spin or anything like that. So what is the purpose of a cloud native application? Anyone understand the Scottish answers? To store data in the cloud. I'll put on my Scottish accent for this one. To run applications on local servers, to build applications in the clouds, or to develop mobile applications. Anyone think they know the answer? All right, let's see, to build applications in the cloud. Yaldi. All right, let's try extremely, oh, I can't even type. Extremely difficult. Oh, come on, you can do better than that. Let's see. I'm not sure if I'm really offended by its Scottish either, but. Anyone know what Bampot means? All right, so what is the meaning of Kubernetes, your Bampot? Thanks for that, OpenAI. A system for orchestrating and managing containerized applications. A wee beastie you find in the Highlands. A fancy name for your cloud-based haggis recipe. Okay, and a slang term for skipping rope made for cloud fibers. All right, so we're obviously going to get that right. If you get it wrong, I'll say rang. I am going to give away a PS5 or an equivalent gift card. And if you want to win that, all I want you to do is just play around with the topics and the difficulty, screenshot it, post it to Twitter. The handles are at the end of the talks. Based on the amount of people in this room, you've got a pretty good chance of winning. So please have some fun with it. And the funniest one we'll throw up, right? We'll do one more, just because I'm curious of what it's going to spit out for Stargate. What is the name of Stargate in the film Stargate? AI. I'm pretty sure AI is going to take my job at any minute. What planet is featured in the pilot episode? Abydos. All right, that's enough of that. So how do we make this work? Well, to create a Spin application, you can just run Spin new, but I already have one. Now, I'm really going to focus on the DX here, and I've got like 10 minutes, so I'm going to go a little bit faster now. But we already have everything that we need to build microservices with WebAssembly when we use Spin, right? To the point where as long as I have a spin.toml in a directory, I can run spin add. I can then pick a template, and it's going to add a new microservice to my application. When I do this, I get it mounted to a root on my application. I write my function, and that's it. These functions and these WebAssembly modules are spun up on demand, giving us that real dynamic orchestration. Now, my terminal sometimes struggles with this, so I'm just going to say HTTP. Anyone got a prepared language of choice? Go. Go? Ugh, you make this hard.
You gotta fix your HTTP.
Thanks. Go. Let's call this the hello world component. We'll mount it at hello world. Oh, hello world. Why does it not allow dashes? Oh no, it wants a slash. They should fix that. All right. And now we have a new component at /hello world. So let's take a look at the code. I know the sidebar is always a pain, right? But in the quiz directory, we have our new directory here, which has domain.go.
Nice.
And now put it down. We get a function, we have a handler, it says hello Fermion, and we can build and run this application locally. So we can now do spin build. Now what's actually happening here, oh, I don't have TinyGo installed. Spin does still require TinyGo because obviously Go 121 is pretty new. What? Oh, you had to pick Go, didn't you? Let's just remove it. Spin, add HTTP, and the right answer is always Rust. So, hello. Okay, let's just do this quickly. So I'm going to build this. Now, what's interesting here is that
Stuck with Go.
no, we're not stuck with Go. We just have to open our spin.toml and remove the Go component. And I'll run you through this in a wee moment, but let's just delete our Go component. So what's cool here, right, is building a Rust function that we just added. It's building a Rust function that I previously built, and it's building a static website, which is built on the Astro framework, packaging it up, and then shipping it all together in a single WebAssembly module. So we'll let that compile, because Rust is notoriously slow. But what we have here is a web application built with Astro. It doesn't matter if you know what Astro is, but it's just a static site generator that does fancy things with JavaScript. Basically, my front-end team just work on this, and they never really need to know anything about WebAssembly, and that's the way that I kind of want it to be. This is then, like I said, rendered to a static site and shipped and served over a WebAssembly-based file server. We then have a Rust endpoint here. Now, what's cool about this is that we're doing a whole bunch of structs to handle serialization as we speak to OpenAI, but I'm going to just omit and skip over that. We then have our function, and the way that you get a Rust function to compile, to spin, and be WebAssembly is just to add a procedural macro of HTTP component. In this, we're using the Spin SDK to fetch variables from Spin Cloud or from the local environment for developer mode. So I'm providing my OpenAI token via 1Password secret injection. But in production, when I deploy it to Fermion Cloud, it is stored in Vault and managed for me by Fermion. I have my wonderful error messages as I process the request, and then we speak and send HTTP request to OpenAI. Here's the prompt that I'm using where I say, use the Scottish thing and allow the difficulty. And I just love OpenAI and the fact that I can say, and give me JSON that looks like this. And to be honest, it's not failed yet, which is really sweet. Once we get that, we spit it back and send it, and that's it. Now, the Rust Hello World one is obviously going to be a lot easier. So let's take a look at that too. You can see here, we just send an HTTP response. So as we add more and more functions to our application, we can just run spin up. And I will need 1Password run just for the OpenAI token. This mounts everything, all the functions to the correct path based on my spin.toml, which I'll go through in a moment. As we add more functions, you can see they just get added to the end. And then you can just start to curl it. So if we pop back and do localhost 3000, we have the website. And if we do hello, we have the hello Fermion endpoint. So we're shipping our functions and our static website together, which I love. Now, the way that this works is when I run spin build, it processes the spin.toml. So we add, I hate toml so much, but we define the components. So let's look at the file server one. This long path is just another project from the team at Fermion that does the file serving stuff, and we just point it to the directory, the web dist, where all those files are, and it will handle serving them. The component trigger for this is just a wildcard path. So it just says anything that we don't understand from any other component, we route to the static file server, and then we configure the build step, right? So we're just having it run our npm run build for us, and we can configure a watcher. So we can actually use, what's really cool is your development experience is now just run spin watch. And whenever any of my projects change, it's just going to go and rebuild that and ship that for me. So we get a really fast developer feedback loop. And I have my wildcard a bit too permissive because it's rebuilding because the build is actually building. So don't do that. Then we've got a Rust component, which has the config that we need. So we're just saying this requires an OpenAI token, and the variable is defined at the top as required. So the variables are defined globally, but you explicitly tell the components which ones they are allowed to access. And then we have our new one that we added at the bottom. So once we're happy with that, we go, cool, let's ship it. We're just running spin, cloud, deploy. This throws it onto Fermyon Cloud, which is free. You can host up to 5 applications on it. The traffic isn't really metered. It's just fun to play with. And I've configured it with custom DNS, which is why you can go to quiz.rawcode.win. So you can just start shipping WebAssembly applications to production today. Now, of course, you can also do this yourself. You don't need to use Fermyon Cloud. You can use Kubernetes, and there are other sessions on this today as well. So I think the future for WebAssembly and Cloud Native is exciting. I'm really looking forward to more architectures where we can bake WebAssembly in. I think the developer experience is better than what we have right now, especially on Macs and Windows, etc. Thank you so much for your time. Remember to tweet your funny questions and answers. We will give away the PS5 tomorrow. And if you want to learn more, I used OpenAI, but today Fermyon have just launched their own AI support, where you can do your own embeddings and use Code Llama, etc. And they have a really great SDK where you just provide enough details. You don't have to worry about HTTP requests and all that stuff. So the demos are available on GitHub. Mikkel, one of the developer relations people at Fermyon, has got his own demos there. And there's the sentiment analysis demo too, which runs on their embedding AI. So you can just come to this website and say, hello, Marino. And it will analyze it and say that that is neutral. So you put your hand up, I had to put your name on it anyway. So yeah, tweet your photos. I hope you enjoyed this talk. If you have any questions, I'm happy to answer them now. So thank you. Yeah.
So what does networking look like in WASM?
There's no such thing as networking.
Okay.
So this comes down to the runtime. WebAssembly and the WASM spec purposely doesn't allow any networking whatsoever. You can't create sockets, you can't do HTTP requests, you can't read files. The sandbox is really, really restrictive. Excuse me. So the way that these are added is through a concept called the component model. So Spin has a whole bunch of components that bring it in networking, file system access, database access that they attach to the runtime, which is like, if we take a look at my...
So does that effectively allow me to implement policy for any of these WASM functions if I wanted to at a network level?
So yes. If we take a look at my spin.tom, well actually, it's not really a policy, but the networking component, the HTTP component that the component model is provided by Spin allows me to restrict host-based access based on the Spin configuration. So here I'm saying I'm allowed to speak to API.OpenAI. So you can add those. If that's not permissive or restrictive enough, you can then provide your own components with your own set of configuration and apply the policies and the rules to it yourself. Obviously a lot more work, so it depends on what you're trying to do. And this is true for file system access too. If you want to make directories available to a Spin application, you could say mount this directory, read only, read write, etc. And you would layer these components on, and it's all governed by the runtime itself.
So you can give a function access to a database, for example, like full or query or something.
Yeah, so you can either give it network access and it can go speak to your database, but you could also just write a component that says you're allowed to run selects on this database table and stuff like that. Again, more work. You need to build. WebAssembly is mature and you can use it in production, but the component model is relatively new. So the WASM spec is pushing towards 1.0. The plan is to be there this year. And the components, I'm assuming you can just start working on them now to that spec, and it's hopefully not going to deprecate. Thank you. All right, any questions?
Hi there, thanks for the talk. What are the obvious advantages of
Yeah.
So thank you for your talk. I just want to ask, what are the obvious advantages of running WASI or WASM in the cloud over something like Knative or OpenFaaS?
So the main advantage of WebAssembly there is the WebAssembly binaries are much smaller than container images. WebAssembly binaries probably going to be 30, 40 meg. Now you can get container images down to that size, of course, but then containers do need a Linux process, they need an IP address. All of that infrastructure takes hundreds of milliseconds. So when you want, this is something that Knative and OpenFiles would love to be able to solve, right? But as a new function comes in, it takes, let's say, 300 milliseconds before that request is going to be started. Maybe you can get that down to like 100, but I'm not sure. This is why they now all do slightly longer living processes in containers that then handle 1 or 2 requests, 5 requests, 10 requests, whatever. They can configure that, and then it shuts down and tries to scale back up as demand increases. But with WebAssembly, all of that just disappears. Like when you can start a WebAssembly binary in a millisecond, just spin one up for every request. Kind of that promise of what we had from unikernels, 8 years ago. We're now getting to a world where that can actually happen. So yeah, it's quite exciting.
Thank you very much.
Just want to ask, what's the right way to write functions? Because obviously you wrote a single HTTP request. Sorry? I just wanted to ask, what's the right way to write functions in WASM? So like your example, had a single HTTP endpoint, but obviously that's never going to happen in reality. You're going to have 20, 30. Does that mean you would write a single function for each of them, or what does the entry point look like?
Yeah, so this comes down to your own personal way that you want to structure your application. So you could run spin add for every single endpoint and every path in your architecture and have a different language if you want, handle it, and you're done, right? But a lot of people are still more comfortable by having a little router. So if you want, you could have a catch-all wildcard function, or maybe it does a subset of paths, and then you can have multiple functions within that, and then your entry point is a router that says, if this, go here, if this, do that. People use router for JavaScript, there's one in Rust, so if you want to do that, you can. But I really like single function, single artifact approach. I think it works really well.
Gotcha, thank you.
The other nice thing, just in related to that, is that if you decide to write everything in Rust, you can have common libraries, you can publish crates, you can consume all of that, you can share it all. I even compile Rust into a WebAssembly module I load in the browser. That old chestnut of the backend server validates the form like this, but the front end does it slightly differently. You can just reuse all of that logic across the stack, which is also very sweet.
Very last question, if somebody wants. Okay.
Okay, thank you for your time.